Once a site has been selected for exploration, a rig is brought on location and drilling begins. When the well is completed, if deemed productive, 7 5/8" casing is installed and cemented to total depth. The rig is then disassembled and moved off location. A permanent wellhead is installed and the well is cleaned out and prepared for stimulation. Next, a service crew and equipment is brought on location to perforate the targeted zone. A perforating gun is then lowered into the wellbore and landed at the toe of the cased hole. A charge is activated and establishes a pathway between the reservoir and the wellbore. The well will then be stimulated by a process called hydraulic fracturing. At the frac stage, the femto technology is pumped down hole after acid and a water spacer. Mako's products are powered by a proprietary chemical, which is a tetrahedral silicate monomer with increased electron potential. Although the chemistry is proprietary, the manufacturing process of the primary chemical uses natural properties of silicon, sodium, and oxygen to form an extremely concentrated alkali product that has a femtoscale molecular structure that affects the attraction and repulsion of hydrocarbons to mineral surfaces. Mako's products are highly concentrated and saturated with excess OH groups. In the oil-bearing formation, the Mako formulations readily seek to disrupt weak hydrogen bonding that is associated with crude trapped in the formation pores. The natural tendency is for the chemistry to penetrate the formation pore space, break the hydrogen bonding and surface tension that traps the oil, and then physically displace the oil from the space. Once the mineral surface is exposed to the chemistry, the surface is much less attractive to oil, which allows the oil to move. It is water-soluble, which causes rapid dispersion as it readily moves through the near wellbore area and formation. Its proprietary technology continues to penetrate deeper and further into the formation until the electron exchange is spent. This creates added value since no additional pressure is required for it to migrate deeper into the fracture network where no other stimulant chemicals have gone before. Mako's formulations have unique characteristics that are based on its abilities to affect an ion exchange, interrupt weak hydrogen bonding, reduce surface tension, reduce corrosion, and protect metal surfaces. Mako uses femtoscale technology. 1 femtometer equals 1 quadrillionth of a meter. Thus, these formulations more easily migrate through the formation pores. Femtoscale molecular structure readily seeks to disrupt weak hydrogen bonding, increasing permeability. Mako's proprietary technology penetrates the formation pore space and displaces the oil, thus promoting efficient separation, releasing oil deeper and further into the fracture network, enhancing flow characteristics, dispersing paraffin and asphaltenes, and providing protection to the formation for increased production. This increases oil recovery and, in turn, increases return on investment.